In this video, we are going to learn CQRS design pattern with event sourcing pattern. In the last video, we have learned the CQRS pattern, and the CQRS pattern is mostly using with the event sourcing pattern. When using CQRS with event sourcing pattern, the main idea is store events into right database, and this will be the source of truth of that events database. After that, the read database of CQRS design pattern provides materialized views of the data with denormalized tables. Of course, these materialized views read databases consume events from the write database and convert them into denormalized views. The writing database is never save the status of data, only events actions are stored. By this way, saving only events actions into write database, we can store history of data and able to reply any point of time in order to regenerate the status of the data. So with following the event sourcing pattern, the system can increase the query performance and scale databases independently. Here you can see the image on the slide, an example use case for applying CQRS and event sourcing pattern. Event sourcing pattern offers to save all events into database with sequential order of data events. This event database called event store. Here you can see the event store in here. In this architecture, we are not updating the status of data record. It appends each change in a sequential list of the events. So that means this event store is become a source of truth for the data. After that, this event store convert the data to the read database with following the materialized view patterns. These convert operations can handle by publish subscribe pattern with publish event to the message broker system, and this will consume from the read database. Basically, this is the use case of adding item into shopping cart for our e-commerce application. So we applied this use case with CQRS and event sourcing pattern. As you can see that for shopping cart, every user actions are recorded into event store with appended events. For example, item 1 added, item 2 added, and item 1 deleted. These items all saved into event store, and all these events are combined and summarized on the read database with denormalized tables into materialized view database. So with this operation, the latest status of the user's shopping cart can be queried from the materialized view database. The user can see latest shopping cart status from the materialized read database on the e-commerce application. And as you know that the writing database is never save the status of the data, it is only save the events actions are stored in the event store. By this way, saving only events actions into writing database, we can store history of the data and able to reply any point of time in order to regenerate status of the shopping cart. We can use event store write database with Azure Cosmos DB, Cassandra DB, event store databases, and so on. So with following the event sourcing pattern, we can increase the query performance and scale databases independently. But of course, it has some drawbacks. The main drawbacks are increase the complexity, because we have two databases and one message broker that synchronize them using events. That makes the complexity our system. And also we should embrace the eventual consistency. There will be some delay when the events being generated and denormalized data store being updated. So this will be forced following the eventual consistency.